Hi, my name is Yash Ahuja. My teammates are Handa Zhang and Qingyou Zhao. In this video, I'll show the material tool me and my teammates have been working on for CSCI 424. Our material tool is a Python tool used for describing materials using a node-based graph system. We are inspired by similar features in Unreal and other engines. Once the user has constructed a graph, the user can export fragment shaders and material specifications corresponding to the material directly into Professor's engine, which is called Prime Engine. These graphs are type checked, so the generated shader is always correct, and additionally, these graphs can be saved or loaded to JSON for subsequent use and modification. In addition to integrating the tool with the engine, we also added support for material instancing and manipulating uniform parameters so the materials can be manipulated at runtime. Here's a graph explaining how our tool works. First, the user will build a graph in the GUI, which he wrote using PyQt5. Then, when they export the graph into it, it's converted into a JSON representation and fed into a generator that we wrote. The generator type checks the graph and reports any errors. If all the graph checks out, then the generator outputs a material specification and a fragment shader, which are then fed into the engine at runtime in order to render different materials. Now I'll move on to a simple demo of the tool. So I've set up this demo scene where the soldier will walk back and forth down this hallway. There are two materials that our tool can be linked to in this scene. So first there's this floor material, and that's used to also drive this circle underneath the soldier. I've already set it up so that way when a button is pressed, a uniform is set from the engine side, and this can be used to drive it. So if I press F, we see that the circle changes color and expands in and out. And then when I let go of F, it turns back to green and the soldier continues walking. I'm going to show how we can use the tool to drive the colors of these lights and based upon the proximity of the soldier. So I'm going to close the engine and then I'll open up the tool. So here we have the tool here, and we just set up with a constant node that's linked to the output, and its constant color is blue. So if I right click and I hit generate, then it's going to export the shader and the material spec file, and when I run the engine, okay, and we see here that the constant color of light is blue. But now we can do something a little bit more complicated. So on the C++ side, I've already set it up so that way it expects a uniform of is activated. So if that uniform exists for the material, then it will set it to 1.0 if the soldier is close, or 0.0 if the soldier is not close enough. So we'll make this if node output to the output of the actual fragment shader, and then I'll add a float uniform here that corresponds to is activated. So then I just set that as the first. It's basically a ternary if. So then that's the first thing, and I'll compare it against 0, 0. So if the is activated is greater than 0.0, it's going to set it to blue. Otherwise, I'll use a constant 0 value for the other two cases. Okay, so when I generate this material, it should output the shader, and then I'll run it. And here we go. You see that as the soldier is walking down this hallway, the lights turn on and off based upon the proximity. But we could actually do something even more complicated with the shader. So I'll bring up something I've already created of a more complicated graph that uses like multiple math and like sine of the game time to manipulate the UVs of the light. So I'll just take this and I'll generate the material and I'll output it. And there we go. You see that when the soldier walks down, we have this cool like strobing light effect. This just shows one of the ways that we can use the material. So for this demo, we have this bamboo texture and we make it change over time as a kind of like wetness sort of thing. So we use an ambient occlusion map and bloom and normal mapping and in order to get this effect. So as you kind of see, like it's changing over time and kind of like looks more dry and clean, and yeah, just a cool effect. Just so we show it off. The graph is also fairly complicated, so just to like show that the tool can be used for like a variety of different circumstances and supports the complicated use cases. And for this final demo, we set up like a complicated Wind Waker inspired ocean scene. So we have a custom vertex shader that's used to move the vertices up and down based upon some compound sine waves and the game time. And we also use the tool to manipulate the UVs of the ocean based upon the time. So you see how it's kind of like moving back and forth, kind of like how you expect ocean to. And this is like the effect that you see in Wind Waker. So we do this using compound sine waves, and then just for reference, here's the graph. Here are our emails. Please don't hesitate to contact us if you have any questions. Thank you for watching.